Oh, sorry, I'm so sorry.
There is, I know.
Okay, thank you for coming to Sydney AI and Data Science. This is our last session for the year, so it's been a good year, and thanks for everyone's support. We at the Actuaries Institute are very happy to sponsor this meetup group. We're doing it, I think, almost for 2 years now, and yeah, basically with Eugene's great assistance with that. Actuaries and data scientists, a lot of their work tends to be merging a bit, so a lot of data science tools tend to be mimicking a lot of the actuarial tools too. So it's almost like two professions sort of blending a bit as the tools mimic the actuarial processes as well. We have a group that looks after advances in data science, a committee, and we particularly focus on ethical issues in that space, and also trying to give people tools to help understand where they're not, I suppose, where they're breaching or not looking for things that they should be looking for. With that, I'd like to invite Eugene to host the event. Thank you.
Great to see everyone. Thank you all for coming to our end of year event, which is usually our most relaxed and our most happily chaotic event. As you'll see, I'm not super organized for this one, but hey, I don't need to be, do I? So here's how we're going to do it. I'm going to go through the list of emails I received of people agreeing to do presentations, and the list might not be perfect. So if I've missed you, well, that's your opportunity to remind me when I get to the end of the list. There's about 7 of you. So each of you will get 5 minutes to present. I will be timing you and I will be stopping you. Regarding questions, well, that can be in your networking session at the end. Yeah, I'd rather leave time for additional presentations. So once everybody who's scheduled a presentation has presented, then any of you who want to do an impromptu presentation are also welcome to do the same, and then we'll break for our usual networking session, and you can ask whichever presenter that hasn't run away any question you like within reason. So with that, let's kick off and invite, do we have an Alistair Rigney among us? No Alistair Rigney. Okay. All right. Well, I think I know who Renee Somber is, and he doesn't look like he's here either. This is a promising start, isn't it? Well, which brings me to Alan Nugent.
6 minutes.
We're making you sweat. You can have to. And a bell at 5 minutes, and then you've got a minute. Yeah, okay.
Okay. How do I find it? I emailed it.
So I haven't received that email yet.
Technical issues.
While we're solving our technical problems, and you can play your own waiting music that you like in your heads, we might move on to our next speaker. And the next speaker is our very own Demeter, who only gets 5 minutes.
much. I hope I can find where the folder is that I should have taken. This is not touch, right?
So there'll be a bell at 5 minutes.
Okay.
Ringing bell at 6 minutes.
All right. So just introduction, quick introduction. I've taken the Socrates advice. Written is never as good as talk with communication. So I didn't have time to waste on PowerPoint. Now I have something else to test. Yeah, I'll fix that. Okay, thank you very much. I'll test something else first before going to the most interesting one, just to see whether there's sound. Okay, good. Is there sound?
Pretty much.
Visuals.
Because that would have been good, but I have to explain that. Okay. Where's the stop here? I wish I have set up my mouse because I never use these things. All right. And the other one, I guess, when I start will be fine. And one more thing. Okay. All right. I think the only thing is to make this smaller so we can navigate and then go to this. Now, sorry, I guess this doesn't count. Collapse the ribbon. I don't want that. I should have brought the mic. And I don't know if that interferes with you, but it's just would have been good if I removed this the bottom because. All right, regardless, I'll just make it a bit larger and then we can go up and down this way. Okay, good. All right. Sorry.
How many of his 5 minutes have we used up?
Okay. All right. So the strategy about, because this is much more, like could be 555 minutes, but I'll just stop when 5 minutes comes. And then just a second, we have some sort of counter, quick, voice, save. All right. Okay. So I picked this topic because I always wanted to look at the things from a holistic point, and I was planning this long time. I said, like, the only way to do it is if I enforce myself and say I'm going to present this, so I've got no other choice. So if you remember, the key dimensions or elements of data science was methods or mathematical, statistical modeling, then tools, and then business, which is usually in business they pick 2, but you need to pick 3 because otherwise it's like wasted effort. So I thought, okay, that's great, but let me go to the next level, which was the bonus 6 thinking heads, and they're like, double, that's great. And here is just a quick reminder about the bonus, like white, which is facts, great for us. Red, which is intuition, something that most of the people do. Yeah, yellow, which is optimistic, black is judgment, negative, green is creativity, and blue is the thinking process. But now, let me see the motivation. So going to extend this, I thought like 3, why don't we have 3 for each day of the week, so 21. So the resources for 21 lessons of the 21st century. And as you can see, there's 21 after meditation. Not all of them are directly relevant, but they all actually help to better understand what Einstein said. If I have 1 hour to solve the problem, I'll spend 55 minutes to understand the problem. So looking from all aspects is very important, not just jumping to the solution. Like, all right, so now We have global problems in the area of global understanding the challenges, which if we act with better humility, cooperation, we can solve the problems by adding more human values. And that thing here is my sort of hypothesis, the formula that AI is always less than human intelligence multiplied by the collaboration or communication squared, because we have at least two, people we never communicate with one. And so practically that's, equivalent to E equal MC squared, the sort of analogy. Now, I'm going to jump some of these, and I'll just go quickly, just a quick refresher to show you this. Where's the other? Okay, here. I don't know whether the sound would have been nice. So this was about the small robot convincing the other robots in the sort of presentation, room, say, "Are you still working at this time? Let's go home." So this shows how the AI revolution is going to end. They're probably going to show us how we should act rather than being robots ourselves. Because my hypothesis is that, not a hypothesis, that my observation is that I'll come to that point actually now. So the first point, quickly, what's the timing? Sorry, oops. So the humans are mostly related to stories, which is unfortunately because what we're doing now is mostly about evidence and actually using data-driven decisioning culture to actually solve problems that matter, not just what we have like a gut feeling what's happening. So related to converting to our sort of domain, that means we need to redefine our data concepts about storage and processes, rely more on graphs, which are a better way to represent the data, real-time clouds, and then all these methods of LLM, big data, analytics, mesh and fabric is in the data governance domain. What will be impact will be the work impact. So many people will come to the precariat sort of point when they'll probably there won't be jobs, but as you saw, the robots can find solution. You don't need to work like crazy, and all right, the rest they can leave for the oops. Okay, so just quickly, the other domains. So what's the most important? We can discuss later how regarding the equity, that actually there's an opportunity for the people with money to actually buy their power by actually becoming more intelligent, even though they are not today, but then they will have the tools to actually become more intelligent and healthier. So we need standardization, and regarding, let me just see what else. I guess we have to wind down, but we can discuss all these things. From the point of, this is interesting or challenging. AI forecasts that in the future, the people will work 3.5 days per week, but 3.5 times worse than what Keynes predicted, that we'll only need 2 hours per day. All right. Thank you very much. Welcome for discussion after this. Okay. So actually, sorry I stole your minute, but.
Are you ready to go out?
I think so.
So let me just close this.
You've met all my expectations.
So, okay. I didn't discuss about that, but I guess we can move.
Just goes to show.
Thank you very much. Let's see if Alan can follow up.
This one here?
Yes.
We are ready.
So virtual nurse is a project I've been working on for about 4.5 years, dabbling for the first 4, and then seriously for the last 6 months or so since I resigned from Health Direct Australia. What it's about, as you may have guessed, we've got a perfect storm shaping up in aged care. While residential care numbers are fairly static, largely because there's no more spaces, home care is increasing by around 5% in demand every year, but the number of care workers is really going down, and 30% have said they want to leave the industry within the next 3 years. Expenditure is going up faster than demand because of rising costs. We're probably at close to 30 billion for the next financial year. Yet most people want to stay in their own home if they can be able to do so safely and in good health. Now, the problem in the startup world is that everybody tells you need to pick one niche thing and own it. But aged care is not one problem, and niche solutions are just not catching on. For consumers, there's all kinds of issues. There's the lead time to get into care, even the lead time to get assessed to be admitted into care. There's a difficulty in obtaining carers. There are cancellations when something like 25% of the time in some areas. When there's an escalation in the need for the level of care, there could be family shock. It's always hard if someone has to move into residential care suddenly. And 80% of people who live on their own as they get older say that loneliness worries them more than anything else, including heart attacks and falls. Care providers are balancing recruitment issues, training, staff retention, poor commercial performance, and increasing regulatory burden. But I'm thinking while there's not one problem, there could be one solution. What you see on the left is the conventional approach, lots of niche solutions like smart speakers and apps with lots of different screens, wearable devices. I'm suggesting that we build one solution which packs all those or wraps all those other ones behind it. So a lifelike avatar with a natural speech interface, it integrates with telehealth, with ambient and wearable devices, with the scheduling of the care providers, with scheduling of social outings. So as you can imagine, this is relying heavily on an AI solution. So I'd just like to quickly recap where we're going with chatbots. The first generation, of which the earliest and most famous probably was ELIZA, was limited to heuristic rules for inference and intents. It drew the responses from canned, pre-prepared ones, and reassembly of things that the user said in the prompt. So it was clumsy and yet surprisingly effective because the users thought it was empathizing with them when it was repeating their own words. In the second generation, we had large-ish language models, which could be fine-tuned by the user to specify examples for the intents and entities. Sorry, not the user, the designer. The notion of slots for capturing data that was needed for performing a task, and procedural handlers for the different intents. And when it dealt with an intent it couldn't cover, it would say something a little smarter like, I didn't understand, or it could transfer to a live agent sometimes. But with the advent of large language models, we don't even have to specify the intents and entities up front anymore because it can figure them out. And we can use retrieval augmented generation to customize responses from a curated piece of or set of information. And we can handle the response in lots of ways with procedures, agents, and transformer-driven handlers. And although we don't really have to worry about uncovered intents much anymore, we do have to worry about hallucinations, which has kind of taken their place. But we're tackling those with methods like stacked models or procedural approaches to incorporating a model in a loop, or ranking the responses according to metrics. The applications of AI and ML in aged care are limited only by your imagination, perhaps, but broadly speaking, detection, trend inference, and prediction. So in detection, we can pick up adverse events like a fall, like a cry for help. We could measure adherence with doctor's instructions, perhaps, if we get the user to indicate, well, did I go for a walk today? Yes. Did I take my medication? Yes. We can infer things from the indirect signs about their physical activity, and we can get them to take their vital signs, all very useful. Doctors know about white coat syndrome. They would prefer patients to measure their blood pressure at home before they come in. Mental health and socializing. And for prediction, which is an emerging area, we can detect false susceptibility. We can predict seizures, working on detecting cardiac issues and depression. Considerations in aged care, especially personalization, is important because that's the way to make people engage with this thing is they've got to anthropomorphize it. So it's got to understand their routines, their interests, have their social contacts, and it needs to deploy effective empathic responses. If I cry out in pain that I just broken my ankle, I don't want it to smile and thank me for sharing. But fortunately, AI is good at stuff like random sentence structure. Some of them can handle digressions, colloquialism, and dialects. So it makes it more natural. It's easier for people to start treating the thing, not quite as another person, but at least as a proxy for their GP. Then, of course, we have to deal with responsible AI, safety, efficacy, hallucination, etc., and discrimination. So there's plenty of challenges. And if anyone has got their interest piqued and want to talk to me later, please do. And you can see some demo videos at the website. Thank you.
Thank you very much, Alan. That one was definitely worth the extra wait for. And just confirming, you'll still be around at networking. People can ask you questions. Our next presenter is someone who's been coming to these for a long time, Michael Walker, and the topic is very interesting, close to my heart, actually. It's quantum machine learning.
Thank you, Eugene. While I bring up my slide, I'll just point out that I've been coming for a long time, but I've had a hiatus for the past couple of years because I had family things on Tuesdays.
All right.
So I would have liked to have come. All right, maybe I'll just... okay, actually I need the PDF. Yep, oh, sorry, I had it. There we are. And, oh, yeah, that's big enough. All right, so today I'm just going to give everyone a brief introduction to the progress that's been made adapting machine learning methods to quantum computers. Now, the advantage of this that are emerging is that the quantum machine learning methods generally require fewer samples to train them. They train in fewer training cycles or fewer epochs on your neural network, and the final trained network tends to be more stable against perturbations in its input. There are some challenges remaining, not the least of which is the hardware still needs to be brought up to scratch. Another thing is that uploading the data to a quantum computer is inherently more difficult than for a standard one, although there was a very recent development where a certain genetic approximation will ameliorate that. What I will go into a bit more later are barren plateaus. So this is where the gradients of your parameters tend to vanish exponentially, and that makes your network untrainable, potentially, unless you are very careful in the way you design your circuit. But I've gotten ahead a little bit. A quantum computer does computation by exploiting the quantum mechanical degrees of freedom. So instead of having bits with their zeros or ones, we have quantum bits, or qubits as they're called. And the qubit will be typically in a weighted superposition of a 0 state and a 1 state, and those are complex weights there. And then if I go and look at my qubit, because I want to see what its actual value is, I will get either a 0 or a 1. And once I've got that, the other value disappears and there's no longer an option. And that's an inherently random process. Similarly, if I've got multiple qubits, we'll say 3 qubits in the example I've got there, that is a superposition of a 1, 1, 0, a 1, 0, 1, and a 0, 0, 1. If I actually do a measurement, or I just make an observation of the values in that register, I will get either 1, 1, 0 or 1, 0, 1 or 0, 0, 1, but I won't get all 3. And once I've made that measurement, the other options disappear. And again, it's those complex weights actually determine the probability of which one I'll get. One of the reasons that quantum computers are considered powerful is that every time I add another qubit, I basically can hold twice as many values. That's a good thing, but it's also going to work against us, as we'll see later. Another few more things you need to know. The quantum circuit, right up until the point where you take that measurement, is a unitary operation. For those who are not mathematically inclined, the important thing about being unitary is that the information is conserved. So there's no information loss ever. Nothing's ever overridden, nor can we duplicate or clone a quantum state. Another important thing about unitary operations is that they can be generated by Hermitian ones. And that's sort of it's like a unitary operation, but you've only got real elements in your matrix instead of complex ones. But those Hermitian operators will actually give us a handle later on. So we do all this so that when we encode our problem in this higher dimensional mathematical space, the quantum computer can basically take a shortcut through it that's not available to a classical computer. All you need is the right algorithm, and you can then get better scaling behavior if you have the algorithm for the task at hand. All right, so let's suppose that we've encoded our machine learning method, our neural network, on a quantum computer. We have this problem of barren plateau. So the fact that the space that we're in will scale exponentially is great, but it also works against us because it also makes the gradients with respect to our parameters vanish also exponentially. Now, what's come out very recently, actually only the past couple of years and still ongoing, is that unitary operation that defines your circuit is generated by Hermitian generators. Now, if you close the algebra of those Hermitian generators, you've got an algebra which basically characterizes your circuit, and that can give you a handle on this problem. There are two ways that I'm aware of. One is that if you simply put more parameters into your neural network than you have generators in your characteristic algebra, then you've over-parameterized the circuit, and that so basically solves that problem. The other way is if you design your network or your quantum circuit in such a way that its characteristic algebra reflects the symmetries in the data that you're going to feed to it. So it is a bit of a bespoke approach. Okay. Now, another approach, and this is where you train in a completely different way, you can encode all the possible values that would be of interest to you and then get the computer to give you the one that you actually want. And there's a famous algorithm for this called Grover's algorithm. Going back to that example state that we had before, we had the 3 different components. Suppose we did some sort of test in our circuit and it determined that 001 was the component that we wanted to keep. What the Grover's algorithm does is it performs a series of reflections that essentially rotates your quantum state to point in the direction that you want. So in the example we've got there, we're closer to alpha than beta, but we actually want beta. And if we run that Grover algorithm a few times, we'll get beta. So to my thinking, this is a more elegant and quantum way of doing things. But one thing I know from personal experience is that using Grover in that way is very expensive. All right, so that's the end. I think I've raised more questions than answers, if I'm going to be honest, but I'm happy to answer those questions afterwards. Thank you.
Thank you very much, Michael.
Next up is Sarah, who's going to tell us about her work at NASDAQ.
Okay.
Switch.
Yeah, so my name is Sarah Bradley and I'm a lead data scientist at NASDAQ. So today I'm going to talk a little bit about NASDAQ, what we do in Sydney, a bit about my role in the projects that I've worked on and some other initiatives I'm involved in. So most of you know NASDAQ as the stock exchange based in New York. And while it is where we started, NASDAQ's actually grown into a global technology company. And we provide a range of software products that actually power the financial markets, both from a data perspective and also from a regulatory compliance perspective. So the project that I'm working on right now in the software NASDAQ market surveillance. So we're actually the leading provider of market manipulation detection around the world. So we're used by 15 regulators, 50 marketplaces and exchanges, and we have 140 participants. And so probably the most famous example of market manipulation is The Wolf of Wall Street, if you've seen the movie. Essentially, Jordan Belfort makes a silly amount of money by manipulating the market. And so there are a lot of different types of market manipulation, and exchanges around the world have to have a system to ensure that they're detecting that illegal behavior and cracking down on that. And so the way that impacts everyone is it's very important that there's integrity and trust in the capital markets, because that impacts the price of equities, it impacts other investors. And so this is a very important component of the financial system. And so, yeah, so we're the most widely used surveillance technology, and we're used by a large number of exchanges. And so my role in the software is I'm the head of AI for the market surveillance side. And so I lead the research and development and the productionization of our AI products. So I'll be going through some of the projects that I've worked on this year. So the first one is we did a project with the Saudi Arabian Capital Markets Authority. So they're essentially the Saudi Arabian version of ASIC. And so the main goal of this was to develop machine learning capabilities for market abuse detection. And so the overall goal is we wanted to develop a risk-based approach to monitor for a specific type of market abuse known as pump and dump. And a really core component of this is for it to be adaptable and evolving risk factors. Because as you can imagine, as we catch types of market abuse, people find new ways to manipulate the market. People get very creative when there's a lot of money on the line that they can make. And so some of the challenges when developing detection for market abuse is, of course, class imbalance. So classic fraud detection, you have a very, very small number of true positive cases compared to billions of transactions that actually might be okay. Another issue is the labeled data. So in other fraud detection, then you might have a lot of labeled cases. In our case, these are normally sealed. So there's a lot of legal requirements, so we don't have that many labeled cases. And on top of that, you also have that human element where you don't want to just be catching things that people are already finding. And there's also that human bias where they might find certain things, or they might associate one person with a lot of different cases. And that might not actually line up with the data perspective of what you want to look for. So the data labeling component is quite tricky. Another issue is defining normality and anomalous behavior. So as you can imagine, there's a lot of different equities and stocks in the market. A stock like Apple will look very different from a data perspective than a much smaller cap stock. And so how do you define normality for one stock? How do you not just catch maybe a more volatile stock? How do you figure out what's normal for each stock and make that applicable? And of course, prior probability bias. So if you're looking at within a stock what's normal, you can't just assume that every stock has that. And then if you apply certain probability algorithms, you can't just catch like 2% of everything, because it's not going to be right. So overall, the project was very successful. We were able to develop a machine learning algorithm to detect that market abuse with a 43% reduction in false positives and a 300% increase in true positives. The second project that I led is a generative AI assisted investigations project. So we introduced an AI-powered feature to enhance the processing of investigations. So once analysts kind of investigate the market, they've got to investigate every case. And so when they do that, they've got to look through news and data, SEC filings, peer company news, sector news. There's a huge amount of unstructured data, which is a really good use case for generative AI. So the entire tool is based on cloud infrastructure in AWS, and we also use Amazon Bedrock to access the large language models. Other projects I've done this year is I won the NASDAQ Internal Hackathon for the Asia Pacific region, and I've done several other machine learning and AI projects, really focusing on regulatory compliance, analyzing large documents, and also segmenting the market based on participant behavior. And a few other initiatives I've worked on. So I'm the Australian NASDAQ lead for the Women in Tech Network. So if anyone wants to talk about stuff we can do for that, just let me know. I also work with the AI for All, which is a US-based nonprofit trying to encourage maybe minority groups to get into AI, giving them internship opportunities, mentorship opportunities, and kind of experience working in the field of AI. And the third initiative I work with is Inspiring the Future Australia. So it's an organization that pairs professionals with primary and high school teachers to kind of give young people an understanding of the job market, what different career paths look like, and being able to kind of interact with that, and also promoting women in STEM. So yes, thank you.
Thank you very much, Sarah. Thank you for finishing on time. Do we have Stephen Pascoe here? Please.
Where are we? Okay, many years ago, last century, actually, I was a writer in an advertising agency. My heart's in that area of video and audio production. What we're about to see is a dramatic change. What we already are seeing is a dramatic change in the production of video and audio. If my son came to me and said he wanted to be an actor, I'd say get a real job, son, because there will be no jobs. Already they're being replaced by 3D models. Background, a couple of years ago, the backgrounds are being replaced. They have anti-aging algorithms now. So if you're 40 years old, but you want to look like 20, that can be done on the fly. Unfortunately, only on the screen. I'll show you a few. I'll show you a few things first. Right, my first thing here, I'd like you to suggest to me. Just to the screen. Is it touch screen? No. Yeah. Thing. Yeah, this one here. That's not. That's no. The bottom one. It's coming up. Did a double click. All right. Here you go. Okay, I'm going to ask you a question. What's wrong with this picture? Apart from the fact that he's in church. Okay. If you look carefully, the fingers. Oh, how do I get it larger? Where? So show me. Oh yeah, sorry. Okay, right. No, it's not touchscreen. So right, I can just zoom. Right, okay. All right. This was retweeted by Donald Trump. The fact he's in church, yes, that's a problem, obviously. 6 fingers, a very common error at the moment, but is getting fixed. The things that are a problem at the moment is text. If you type it to put in, you want a sign saying something, it will misspell it. That's very common. I started looking at this 6 months ago. The change in the last 6 months has been dramatic, absolutely dramatic. And the very first feature film was released. It's on YouTube now. The first feature film worth watching. It's called Where the Robots Grow. And there you go. So, yep. Media player. This was produced by about 6 guys. When it comes up, there's no sound. Right. Get past this. I'll fast forward. Right. It looks like something from Pixar. 6 guys did it, and it's well worth watching. The storyline's a little bit, formulaic, but apart from that, it works. So if they can do a feature film with 6 guys, probably about 6 to 9 months in the production and writing, things are going to change. He's already got another. He made a second video after the second feature film, which is now streaming on Amazon. This one here, I'll give you an example. Why isn't it going? Double click or triple. I like mouse. I like a mouse. Right, okay. Here's a picture of Woy Woy Station around 1910, maybe a little bit after that. If you look carefully, with video, you can put text to video or image to video. I imported this video. It made a 4-second. It generally makes it in small chunks. So when you make a video today, you have to actually compile either 4 to 10 second or sometimes 2 to 10 second chunks. It may take 3 to 5 minutes for that to render, to actually come up to be processed. And very often you might go through up to 50 renders for one 4-second or 10-second clip to get the one you want by constantly reprompting. Now I'll play the video that was generated. It's only 4 seconds. It was generated from this picture. Now, what's happening here is a thing called grokking, where artificial intelligence is able to understand these are people, that they have legs and that they're walking. So they give them a walking, not a galloping movement. But I want you to look at this section around here when that man walks, and you'll see an error. And it's a very common error at the moment, I'm afraid. A boy pops out of the ground. You see that now? I'll play it again. Right? You get that. You get people kissing and literally going into each other's faces. This sort of thing is happening now, but it's improving rapidly. Very quickly, this one here, this was a prompt for an American police car. It's driving backwards. You get this sort of contortion. The term is called uncanny valley, when the image looks okay, but there's something not quite right in that case. And then finally, where are we? This one here. These are all the tools that are available. You can use these tools. Virtually all of them have a free component. So if you want, that's it. Okay, that's it. Okay, thank you very much. Thank you. Mouse.
All right, that concludes our scheduled presentations and opens up to the rest of you who have something to present. I can't believe you don't, Sachin. You might as well, Tom. I think I asked Tom first.
No, I want to hear Sachin first.
All right.
I'm just talking about
Hello. So for anyone who hasn't met me, I'm the principal ML engineer at REA, previously at Canva. So since I've changed my jobs, I've been thinking a lot about what does it mean to be a good MLE. Right? So it's been an interesting journey from going from a senior ML to go into a higher position where it really matters, like how fast the team, as a team, how much we deliver. Right? So I think in previous jobs that I've seen, compared to a software engineer, ML engineers are the slower teams, right? So because there's a lot of experimentation. So these are my few little learnings. Few advice, take it or leave it. But anyway, regardless, this is what I've observed. How do I zoom in? How do I zoom into, say, Control plus? Okay, yeah, all right, cool. So in general, I think what you should aim to do is, as an org, a senior ML should be able to deliver a project within 6 months, right? So I know that's a generalization, but that's what you ought to aim for. And I've been surprised, at least from what I've seen, like how often that does not happen. So some of the bad practices I've seen that contributes to this, I think last time I said I love notebooks. I've actually come to hate notebooks. Right? So to anyone, I do apologize. But the reason I hate notebooks now is because it's one way to kill collaboration, right? So as a team, it's all about doing work together, and as notebooks, you simply cannot do that. going beyond that, you do tend to expand the scope of project, right? So have a metric in terms of accuracy, precision, whatever it is that you're trying to get, and go for that, but try not to squeeze the last bit of accuracy, right? So training is one thing, deploying is yet another thing that you need to do, right? So the deployment is just as important, just as hard as the training. By the way, I'm talking from my software engineering experience, so that's why I talk about having code that lives in branches. So if you do PRs, make them short, make sure you merge back into your master branch. But yeah, so one way to hide your code forever is to have this ticket branch final 999, right? So same as untitled Python final notebook 999, same with branches, right? Talking about hypotheticals, right? So this is one thing I see a lot of people do talk about. They talk about what the model ought to be before they begin the project. The way that I've come to do projects these days is to code up every possible model that is possible, right? So take a LLM, take a classification model, just do your code in a way where you can test out all your hypotheses in parallel. So in our workplace, we use Kubernetes to test out all our training processes. It could be Ray, it could be Databricks, whatever it is that you use, make sure you test out all those hypotheses. But there's no point arguing about that before you actually code things up. People getting attached to projects. Now, I think this is in general, doesn't matter if it's ML, doesn't matter if it's software. Your project is very much, it could go away the next day, right? So it's especially true of ML. Like if you train something for 6 months, it's very possible that the product just moves on, right? So it's very possible that it's not worthy anymore. So don't get attached to projects. Just the whole point of this is to try and push out as many projects as possible. Yeah. So as part of that, like I generally don't spend that much time cleaning data. I know it's bad practice, but again, it's all about delivering more and more projects. The number of projects matter as opposed to the quality of the projects. Now, I'm sure that will come to, like, I'll shoot myself in the leg one day with that, but it hasn't caught up to me yet, right? So that's my little mantra, right? So keep going. Engineering is not about coding, right? So I think a lot of people do obsess about the code that you write, but it's also about communication, about writing your design docs. It's about the code that you don't write, right? So it's about talking to each other and making sure it's the right solution to the problem, right? So for example, like one mistake that we did in our last project is we had a Gen AI project and we came across this fancy tool called LangChain. So there was a person who chained up 2 LLMs, right? So yes, it worked perfectly, but the thing is when it comes to deployment, you simply cannot afford to deploy 2 LLMs sequentially, right? So it's what we end up with was with the classification model, which worked just as good. And just the final little learning that I've had is that machine learning is very forgiving, right? So this is probably more true in Gen AI field. And what I mean by that is, like I've seen plenty of cases where the model predicts a false positive, and then I go and look at the label, and turns out that the label is wrong. Right? So, and even in the case where it is wrong, depending on your project, it could be, as long as you say this AI generated, people will be forgiving, right? So, yeah. Again, final takeaway, TLDR is do your projects as fast as you can. Thank you.
Thanks, Sachin. Tom, what have you got?
Okay, you did. I'm sorry, Sachin's a bit taller than I am. This is totally unprepared. Eugene mentioned it to me about 5:40 today, but that's fine. We have car trips together fairly often and talk about all kinds of things. What I see is the problem in the current direction of AI is that it's got to focus on machine learning in a way that it's about compressing what we know into a form that makes predictions and answers questions. And that depends on the quality of the data and the quality of the instructions. So that is it's a knowledge generation process. It's a kind of part of epistemology, which is it's a philosophy word. But it's about what you know or what you can know or what people are capable of deciding that is knowledge. What interests me more than that is ontology, and that's about what can exist. And it's essentially things like concepts and relationships and entities. It doesn't mean, well, in parts of philosophy, it does mean this. To computer scientists, it doesn't mean what does exist. It means what may exist. And in RDF schemas and things like that, the ontologies define things as maps between concepts and their attributes and their values, or their subjects, verb, objects, if you want to look at it that way. And I use those quite often in my consulting work. It's where I don't walk into a room and ask the people, what do you know? I ask them, tell me what exists in your problem space, what exists in your universe. And that then fits into not just an ontology schema, but an actual ontology that corresponds to their world. And then I'll look at their data resources and what they measure and what they know to see which parts of that ontology that should exist aren't in their business. And that's a scary thing for them at the time, because I'm not asking them to tell me everything they understand. I'm asking them to reveal what they don't understand, or what they've ignored or forgotten, or they decided it's not in my current myth of the business, it's in some other, it's a competitor down the street. So that's kind of 2/3 of my completely off the top of my head talk. The third part is when I go in with that scary thing at the beginning, I also add a scary thing at the end and ask them, after saying, well, this is all the things that you say you know, these are all the things that we found out you don't know. Now, how do you use those things? And if it's a good business, then they should be using their data and knowledge and information to make good decisions. And then looking at how they make decisions, it came back to them from me. Now I've gone over, I haven't gone over my time limit, I've gone over my brain limit. The decisions that they're making may not be linked to their true business objectives. They're linked to their current culture and what their KPIs tell them they should be doing. And within the next 3 months, they've got to make 3 more decisions or 12 more decisions. But it's not something about progressing the business or making things better or generating new products that you didn't know you needed to produce before. I should ask Eugene a question now. That's about the limit of what I wanted to say. If I keep talking, I'll just blather it out. So ontology, oh, not today, but on epistemology, what you actually know, how LLMs are about the knowledge of working out what the next word is, which chains together to generate summary tables with some rigor. Ontologies that are about knowledge structure, not knowledge structure, about things that exist that you should know about. And if you find out you don't know about them, then bloody well go and find out. And then once you've come to terms with those 2 business problems, the third business problem that's data informed is what proper decisions are you going to make? So, and I didn't even get Bill's bell.
All right. I guess I get to be on the soapbox now. Thanks, Bill. You're the best. Just a few thoughts, not very well formed. But things have been bugging me about this whole AI thing. I just want to get them off my chest in some order. I've been bugged by this whole framing of AI in the business world as, first of all, a data science thing. Now, yes, there is machine learning at its core, But do you need to know any machine learning at all to actually use an LLM well? I mean, how much do LLMs, how much does making use of an LLM have to do with machine learning? Here's an analogy. How much of being a social media influencer is about being really good at telecommunications engineering? It's the same sort of question, isn't it? Look, the fact that LLMs came out of machine learning, frankly, we've got maybe a year, if we're lucky, a few years, before everyone wises up to the fact that it's got nothing to do with us anymore. It's there for the whole world. It's there to solve not just data problems, but all problems. You know, it's applicable to the stuff we do, sure, but it's applicable to everything. That's my first point. My second point is one that frustrated me immensely when LLMs even weren't around. So for decades, I was watching management hype up data science. Oh, we love data science. We're a data-driven organization. We're wonderful. Tremendous amount of money being pushed. Enormous headcount. People with PhDs. Huge projects. Lots of success stories. But these were all vanity metrics. Value wasn't being created. Cut through, you know, that actually resulted in organizational change wasn't happening. And 2 decades later, executives were just as disengaged from analytics as they were the 2 decades before. The excuses were mostly the same. Oh, we don't understand this data stuff, and it's not our job to understand it. And by understand, even understanding what questions to ask. So yes, hiring a whole bunch of data scientists, but not knowing how to instruct them, how to guide them, it's all part of the deal. Now, what's interesting is that there's kind of an excuse there, because at the end of the day, the data stuff is hard. Engaging with data, thinking critically, thinking from evidence, having to do politics in a world where objective facts exist and curtail your political locus of action. These are all okay. These are all valid reasons why data science is a problem. But when it comes to AI, I'm a little perplexed, because with AI, it seems to me there's no excuse for every single person in the organization. I'm talking about the people at the very top, not to engage with AI directly, consistently, intimately. But is that what's happening? Is that what you see happening? No, it's still, AI is still the technical thing, right? And I'm still hearing people talk about use cases for AI and you know, what are our use cases? And you have organizations where they have great AI initiatives, but the reality is that the rank and file employees can't just use AI for their work. No, that's a bad thing. We've got AI locked down, but we've got these gigantic projects that we're going to be bragging about in conferences later, and we're spending enormous amounts of money on. So there's something broken here. There's something wrong here. And it occurs to me that the right analogy for AI is not machine learning, is not engineering, is not large projects, it's not use cases. It's a search engine, and it's the iPhone. It's technologies that became ubiquitous. Everyone uses these, yeah? As soon as they appeared, everyone grabbed them, everyone used them. It changed the way we all worked. But none of us had to go and fill out a survey to prove that we were increasing our productivity by using these things, the way people are having to do with LLMs. So yeah, that was a bit of a ramble. I didn't prepare it, but something's broken. Thank you. The other hat. Thank you for coming to my TED Talk. We're gonna, well, does anyone else have any presentations? Anyone want to give a talk? No. All right, so the way we usually conclude these proceedings is we give people an opportunity to make announcements, and usually announcements are hopefully in the form of job opportunities, or indeed any other announcements you may want to make. So anyone? And yes, Michael.
He's a mic.
So you may have heard me mention a few times in my presentation that I used to work in that field. I don't anymore for reasons of redundancy. So if anyone has any interesting machine learning / data-oriented project that they're looking to recruit someone for, I'd like to talk to them at some point tonight. Thank you.
And yeah, yes.
Hey, good evening all. My name is Aravind, and until recently I was working as a strategy manager at NBN, and similar to the gentleman before, I've finished and I'm currently taking a break. And if there are any interesting math or data analytics types problems, not necessarily for a job or anything, but even if it's a role which you want someone to have a different lens to look at the problem and to work with people to solve them, I'd love to try my hand at it. And I have experience in that kind of area. So just thought to mention. Thank you, guys.
Any more reverse job announcements? Well, with that, yes, William.
I'm open for there's a potential role opening that is offering some expression of interest. I don't have the final details yet, but if anyone has experience doing machine learning engineering and wanted to work on productionization machine learning models, as well as getting the hands on actually developing them and doing some kind of end-to-end data science machine learning projects, give me a
if
shout.
only someone here had done any machine learning. Is it too much to hope for? That's a good one. Yes, one more.
Hi, my name is Orion. I live in Fiji. I'm the founder of a small learning center. I'm a software engineer and I actually work for a firm here in Sydney, but I'm interested in speaking with anybody who's been working with AI in education. I developed a small program that basically interfaces with audio-visual with LLMs, but I would like to speak to somebody to kind of brainstorm AI in education. Something similar to Canmigo, if you've ever worked with that.
I'm just the announcement. I don't know if you do this normally, but my first time at one of these events. Thank you. That's the word. And I just wanted to say it's very, very entertaining. And I'm Sam. I work for a CEVO, which is a consulting company in cloud. And we do data and AI as well. And I've got lots and lots of questions for all the presenters today. And just want to introduce myself and say, great event, you guys, from here.
So this was an AA meeting. Everyone says hi. This is turning out to be the least conventional and the most extensive announcement session we've ever had. Don't you think?
You said it wasn't, these nights where,
No, it just all happens. It's just all coming together. So look, let's finish this on a high note and see if there's any pizza left, shall we? And you can. Oh, the meter's got an announcement.
Well,
No. We're not doing problems for everybody to solve. That's the question.
If somebody wants to come to the team that's solving.
Thank you. Let's go.
What problems are they making problems? Making problems is important. After population